Hello everybody. Today we're going to look into the Oliver a little bit. I've had an issue with the alternator. It was right around the same time that the starter was rebuilt and the new starter solenoid was put on. Just prior to that, if you remember in the last couple of videos about this machine, I actually got the alternator working far better than it was by just tightening the belt. The belt was loose, it wasn't spinning like it should have been, therefore wasn't charging. So then I tightened it up and that sucker was charging like crazy. It was shortly after that that the starter had to be rebuilt, and ever since the starter was rebuilt, the alternator doesn't seem to want to charge. I just neglected it. I haven't bothered with it for a long time now. Finally going to look at it. I've found some wiring diagrams and it seems there's a fuse somewhere related to the charging system. So I'm going to try to find where the heck that fuse is. I'm assuming it's somewhere in the console area. So we're going to dive into that a little bit today and see what we can come up with. If we can change that fuse and get it charging, it's going to be a lot more reliable of a machine. So at least I can then replace the battery and get a second battery going so we got some more capacity on board. But let's dive in and see. Well, it's pretty obvious we've got some really crunchy looking wire down in here. Certainly it's been messed with over time. There's items that are just cut off and canceled. This, I think, was the headlight switch. Can't even move it. There's some indicator lamps here that are probably burnt. I don't know if any of them is a charge bulb. That could be part of the problem. I'll get my meter out and tone them. This one's definitely burnt out. That one looks like it might be okay. So a quick test, I can swap them and see if that helps it charge. Alright, we're going to do some digging and figure out who goes where and what exactly I'm looking for. So this is now the following day. After a bunch of digging yesterday, I didn't really have any positive results. More just determining that all the wiring on this thing is really kind of botched back together, or at the very least heavily modified at some point. So I've got the original alternator that was on this machine. What I'm going to do, basically I'm going to hook it back up, but I'm going to bypass all of the existing wiring that was on the machine. So I'm going to eliminate the gauge, the ammeter related connections here. I'm going to go straight from the alternator to the battery, and I'm going to put a little, I'm going to use a light bulb with a socket to make myself a little charge indicator to see if it's actually working like it should. Now that's going to definitely test the alternator once and for all. And if it's no good, and if this one's no good, they might just need a voltage regulator, which I can probably get cheap from a parts store. However, being that this is a Chevette alternator, I've got 2 or 3 more sitting in the barn that are already unhooked, so I can start with those, try them out and see. This probably looks a whole lot Frankenstein. Let me explain. This is the alternator that came on the machine, so I've swapped it back. Step 1, complete. It's grounded back to the chassis like it was when I got it. Perfect. What I did different, off of the voltage regulator, I made myself a little bit of a couple of jumpers here. The number 2 terminal goes straight to battery power. which for right now, for testing purposes, is going to be my jumper cables, because I know that that's a dedicated, reliable joint from battery to alternator, which would replace this wire in theory. From the number 1 pin, I go through my charge bulb, in this case, which should see a voltage drop from the battery to the alternator, illuminate, and tell the alternator to charge until that voltage is the same, and then it would shut off at that rate because there'd be no difference of voltage. So hopefully this crazy contraption is going to actually work. All I got to do is clamp that other positive lead onto the battery and actually hook up the original battery terminal. None of this stuff is going to be utilized at this point. I didn't put an ignition switch on this circuit. I wanted to pretend like, yes, it's on all the time. So as soon as I activate it, I should have some glow coming from that lamp. So let's see what happens here. Okay, I've got my battery terminal reconnected, which means we should be able to crank the engine over. Perfect. Double check I didn't ruin anything by doing that. I was pretty sure everything was out of the way. I think we're going to be all right. Okay, so now we get our positive lead. Sorry for the crummy video here. So this one's my positive. No crazy explosions. Okay, so alternator's on, should be on. So therefore the ignition, yeah, I've got a glowing light. So that means I've got power going through my voltage regulator now. In order to test if it's charging when it runs, we'll get this guy here. Go to DC amps, clamp it, and see what happens. Let's zero it first. Okay. All right, that 1.5 amps may be related to the ignition circuit being on. Let's flip this way here. That should give, actually, if I go up here, there we go. 1.6 amps, which is probably about what that lamp is drawing. So that kind of makes some sense to me. I don't really have a whole lot of confidence in this battery today. So I'm going to do everything that you shouldn't do to a diesel to start it. And just soak it with ether here. You didn't see anything, right? So we're in neutral. Let's crank it. Something sounds a little angry up front, huh? And our charge light's back on again. I don't know if that's the alternator self-clearancing or what the hell that was. If that alternator's just that damn noisy. Alright, I'll try it one more time here. think I finally figured out where it was self-clearancing. It's on that washer at the bottom. That's kind of funny. Oops. I should just make a flat spot on it and turn it so it's not going to hit no more. You can see the little nicks in the fins all the way around, so it'd be better to get rid of it. Make that noise stop. So now, if I shut the ignition switch off, which would actually disconnect the charge lamp from the circuit, it's the equivalent of unhooking this from the battery. And that lamp shuts down. Alternator's no longer energized, so it's not going to kill the battery. Okay. So I think what we've proven here is that we do have charging voltage now, and based on the existing wiring, it's kind of botched. I'm gonna have to go through and replace some stuff to make this alternator charge again. The real question is why it was pulsing like that. I mean, this battery's been on the charger, so the battery should be fully charged at this point, so I don't know if that plays a part in it. I'm gonna actually have to do some research and figure out what that means when something like that happens. Because off the top of my head, I don't know. But once I have a good chance to roll around with the Googles, I should be in a better position to figure out what exactly is going on. All right,